Wind corrections. Calculating drift and ground speed. In both VFR and IFR flying, you almost always need to account for the effects of wind, drift, and change in ground speed. For your planned route, you will have calculated your headings and times pre-flight. But sometimes, such as a diversion, a TC given track, or when tracking navigation aids, you have no other option than to calculate these adjustments on the fly. Aims. By the end of this video, you should know how wind affects track and ground speed, and how to calculate wind-corrected headings and ground speed in flight. The effect of wind. When flying a steady heading, wind will create drift and a change in speed. The effect of wind on our aircraft can be seen by applying the wind vector to the aircraft's vector through the air, its true airspeed and heading. The resultant vector is the aircraft's track over ground and ground speed. This is the aircraft's movement in relation to the Earth, and thus is of vital importance to any navigation. Being able to set a desired track over ground and calculate ground speed is an essential skill to any pilot. So how do we calculate drift on a given heading? Trigonometrically, it is quite simple. At a given true airspeed, the amount of drift varies with the crosswind component based on the angle between the track and wind and total wind strength. Here you can see a precise calculation of drift on a given heading. However, this is too complicated to use in flight and more accurate than necessary. Instead, the small angle approximation is used. This is often also referred to as the 1 in 60 rule to make the maths easier. You start by calculating the max drift. This is the amount of drift you would experience when at 90 degrees to the wind. Max drift is equal to 60 divided by true airspeed multiplied by wind speed. When planning a flight, you can look at the forecast wind at each level and calculate a max drift figure in advance. For a true airspeed, max drift is equal to a given percentage of the wind speed. You can memorize this for your aircraft. To then calculate what portion of max drift applies to a given track, you look at the angle from the track to the wind. If this is more than 90 degrees, you will need to look at the angle from the reciprocal of the track to the wind. If this angle is between 60 and 90 degrees, apply full max drift. For 0 to 60 degrees, the fraction of max drift is equal to the angle from track to wind as a fraction of 60. Let's see how this shapes up to the mathematics. Pretty good. All that's left is to apply the drift to the track into wind to get a wind-corrected heading. Possibly the easiest way to calculate this in flight is using the HSI, or direction indicator, as fitted. Find your desired track on the DI. If fitted, set the CRS to this. Then, look at where the wind is coming from. Now you have the angle and can calculate the fraction of max drift to apply. To find a wind-corrected heading, simply calculate the drift on a given track using this method. Then, apply this drift correction into wind. Now you have your wind-corrected heading. Some people refer to the calculation of how much max drift to apply as the clock code, because the fraction of max drift to apply based on the angle as a fraction of 60 is like the number of minutes around a clock. Now that you have calculated the wind-corrected heading, you can calculate ground speed on this heading. It is important to note that ground speed must be calculated from the corrected heading, not the track. Mathematically, this is even simpler than drift. However, still too complicated for use in flight. To use the small angle approximation, we must make one change, and look at the angle from the wingtip, heading plus or minus 90 to the wind. Again, this is best visualized using the DI or HSI. Look at the angle from wingtip to wind. If this is 60 to 90 degrees, use the full wind speed as headwind or tailwind. If it is 0 to 60 degrees, use the clock code. The angle as a fraction of 60 is the fraction of wind speed which applies as headwind or tailwind. Add or subtract to your true airspeed to obtain ground speed. So how can you use this new knowledge? Perhaps on a diversion or unplanned leg of a visual navigation. Or you may be given a free air track on a standard instrument departure, or by a TC, or when tracking radio navigation aids, or when flying instrument approaches, or even just maintaining the runway central line after takeoff. This is a skill you will use all day, every day, for the rest of your flying career. In summary, you should now know how wind affects track and ground speed, how to calculate heading corrections and ground speed in flight. Thank you for watching. If you found this video helpful, please like and subscribe for more. Leave a comment and let us know what you thought and what you would like to see next. This has been Good Flying Made Easy.